Now we can go ahead and find an equation that helps us to find the confidence interval for a population proportion. Notice that we're finding a confidence interval about the parameter. This interval is supposed to give us specific values that the parameter could take on. We use the data in order to find it, but it is a statement about the parameter. In order to find this, we need to take the statistic, which the statistic for proportion is p hat, then add and subtract from that some multiplier. Right now we only have z multipliers, but I will show you how to find this in a few minutes. We need to multiply this then by the standard error for the proportion, which before we were using standard deviation of p times q over n. But we don't know p and we don't know q, so we have to use p hat and q hat to estimate. Remember, the standard error is an estimate of the standard deviation, which is why we need to use p hat and q hat for this. Now, in order to make sure that we can even conduct inference, we need to make sure that our two conditions for inference are met. The first is that we need a sample that's randomly selected from the population. And second, we need to make sure that the sample size should be large. We saw before that large for proportions meant that n times p and n times q were greater than or equal to 10. But recall now that we don't have p and q, we only have our sample estimates. So we need to make sure that n times p hat and n times q hat are greater than or equal to 10. This actually has a practical application for the problems that we're working on. If we switch over here, we can see then that we've got n times p hat has to be greater than or equal to 10. And we know that p hat is the same thing as the number of people that said yes divided by the total number of people that we asked. So I can cancel out the values for n, and then that leaves me with the idea that the number of yeses needs to be greater than or equal to 10. Following a similar process with the no's, we can do n times q hat needs to be greater than or equal to 10, which tells me that the n times no's over n needs to be greater than or equal to 10, which tells me that the number of no's needs to be greater than or equal to 10. Recall with proportions problems that you're asking a yes or no question, and people will either respond yes or no. So if you have at least 10 people that respond yes and at least 10 people that respond no, you have a large enough sample to conduct inference.